in most remainder and factor theorem question, the working is straightforward, where you sub a value of x into the function to find either your remainder or to solve for the question if they tell you that it is a factor. Okay, but for this kind of question, they didn't give you the polynomial. They gave you that the remainder is equals to 80 when divided by x plus 2. So I want you to make a habit that when it's divided by something, this is your divisor, right? You immediately write x equals to negative 2 on top of your question. Okay, and the remainder of 10 when divided by x minus 1. So what should you do? You should write x equals to 1. Now find the remainder when px is divided by this quadratic function. And you have to know that in Amath, right, most of the times the question, everything is related. Part A is related to part B is related to part C. Whatever they gave you, the information is definitely related. Now before we start the question proper, right, let me talk to you about two concepts that many students fail to either understand or fail to get exposed to or fail to remember. Okay, the first concept is your function is always equals to your quotient, okay, times your divisor plus remainder. What do I mean by that? So if you do a long division, right, and so this is your function, okay, you divide by a certain divisor, what you get, you will have a quotient on top, okay, and you will have a remainder behind. So everything is related to this statement here. The function of the polynomial is equals to the divisor polynomial, quotient polynomial, quotient times by the divisor, okay, plus your remainder. Okay, so this is the first concept that many students fail to remember. Okay, the next concept is if your px, right, is divided by a linear factor, your remainder is equals to a value. Okay, so this value may be 5, maybe 10, maybe negative 80. Okay, and this is most of the time the kind of question that you all will do. Okay, but the second kind of concept that most people do not remember is if px is divided by a quadratic factor. Alright, your remainder would actually be a polynomial form of degree 1. So polynomial form of degree 1, we will write it as ax plus b. And this is the concept that you need to apply in this particular question. Okay, because it says that px is divided by a quadratic function. Now let's start our working proper. So you realize that if you are given x squared plus x minus 2, and when you factorize this x squared plus x minus 2, it will give you x minus 1, x plus 2, which happens to be the two linear factors they gave you at the top. Okay, so now px, when divided by x squared plus x minus 2, remember I told you, we will give you the remainder, which is equals to ax plus b. Okay, so now what you need to do is to put in 1 and negative 2 into your function. What does it say? Okay, so by remainder theorem, what does it say? By remainder theorem, okay, P1 would be equals to your remainder. Okay, and your remainder is, okay, so a bracket 1 plus b is equals to 80. Okay, so you have the first equation, a plus b equals to 80. Same thing when I put x equals to negative 2 here into my function. Okay, I will also give you the remainder. Alright, so a bracket negative 2 plus b will give you equals to negative 10. So I will form negative 2a plus b equals to negative 10. Alright, so looking at equation 1 and equation 2, we will use elimination, because first, always once you reach here, two unknown, two equation, simultaneous equation. Alright, so I would use equation 1 minus equation 2. I will have a minus negative 2b equals to 80. 80 minus bracket negative 10, sorry, a minus 2a. Okay, so 3a will be equals to 90, a equals to 30. Now I put it back in. 30 plus b equals to 80, b equals to 50. Alright, so therefore, okay, the remainder is equals to 30x plus 50. Okay, so the important two things to remember is every function can be expressed as a multiplication of the quotient and the divisor plus the remainder. That's one. Okay, next is if you are divided by a linear factor, your remainder will be equals to a value. If you are divided by a quadratic factor, the remainder would be a polynomial of degree 1. Okay, so this is how we solve this question when you are not given the polynomial and when you are given the factors and asking you to find the remainder.